Now in this session of video we are going to discuss properties of ITF, inverse trigonometrical function. And the first property we have, sine inverse minus x is equal to minus sine inverse x. Clear? Now we have to prove that. For that, we are letting first of all sine inverse minus x is equal to y, and we can write it as minus x is equal to sine y. Clear? Also x is equal to minus sine y. Also x is equal to sine minus y. Clear? And the reason is sine minus theta is equal to minus sine theta. Clear? Okay, now further it can be written as sine inverse x is equal to minus y, and you know that y is equal to what? Sine inverse and if minus is shifted over there, then it can be written as minus sine inverse x is equal to, and y we know that what? Sine inverse minus x. Clear? Okay, now on the behalf of this we can write for some others as tan inverse minus x is equal to minus tan inverse x, minus tan inverse x. Cosec inverse minus x, cosec inverse minus x is equal to minus cosec inverse x, cosec inverse x. Clear? Okay, now we move for the next property, and our next property is cos inverse minus x is equal to pi minus cos inverse x, where x is between minus 1 to 1. Clear? For that, again I will write it as let y is equal to cos inverse minus x. Clear? Okay, so we can write it as minus x is equal to cos inverse y, and further it can be written as x is equal to minus, sorry, it is cos y, it can be written as minus cos y, and x can be written as minus cos y, can be written as in form of, we know that, cos pi minus y, and the reason is that cos pi minus y is equal to minus cos y. क्लियर? ये हम लोग पहले भी डिस्कस कर चुके हैं. जिन्होंने वो वीडियो नहीं देखी है तो वो लोग वहाँ जाके एक बार देख लें कि अगर हम लोग एक क्वाड्रेंट से किसी क्वाड्रेंट से सेकंड नेक्स्ट क्वाड्रेंट में जाते हैं तो साइन भी चेंज हो सकते हैं. क्लियर? तो cos is positive on first and fourth quadrant and it is negative on the second quadrant. So we can write it as cos pi minus y is equal to minus cos y. Clear? Okay, now in the behalf of that we can write it as next what? Cos x is equal to what we have? We can write it as now pi minus y is equal to cos inverse x. Further it can be written as pi minus cos inverse x is equal to y. Clear? Okay, now We have completed this. On the behalf of this, we can write similarly, we can write it as for others. In this case, x must be between -1 and 1. Clear? Okay. We can let it first property. Similarly, b for sec inverse minus x is equal to sec inverse x, pi minus sec inverse x, pi minus sec inverse x. Clear? Again, cot inverse minus x is equal to, we can write it as pi minus cot inverse x. Clear? So now we have completed two property. We move for the in this again property third, we will discuss sin inverse x plus cos inverse x is equal to pi by 2. Clear? Okay, now to proving that, again I let y is equal to sin inverse x. Clear? So sin y is equal to x. Clear? Now sin can be written as cos pi by 2 minus y, and the identity we use, which identity we use? We use sin cos 90 minus theta, cos 90 minus theta is equal to sin theta. Clear? So cos pi by 2 is equal to what? Pi by 2 minus y is equal to what? X. Clear? So it can be written as pi by 2 minus y is equal to cos inverse x. Y is shifted over there. So pi by 2 is equal to cos inverse x plus y, and y we know that what? Pi by 2 is equal to cos inverse x plus and sin inverse x. Clear? Now we have proved this clearly. Similarly, we can write it as, suppose this property we can let 3a, so 3b is tan inverse x plus cot inverse x is equal to again pi by 2. Similarly, cosec and sec inverse, c we can write cosec inverse x plus sec inverse x is equal to what? Pi by 2. In that we have, it is between -1 to 1, and the modulus of x greater than equal to 1. Clear? So that is our property number 3. We will discuss now next property.